Alam natin that infimum and supremum is an important concept in real analysis. So today, we will talk about infimum and supremum, and we will determine the infimum and supremum of some sets. So example number 1, we let S be the set of all x element of the set of real numbers where x is greater than 0. So does S have lower bounds? Or does S have upper bounds? Does the infimum of S exist? Or does the supremum of S exist? So sasagutan natin yan isa-isa. Let's start with the first. Meron bang lower bounds itong set S natin? So ang tanong dyan is, meron bang W, let's say W, na element ng set of real numbers natin such that yung W na yon is less than or equal to X for all X na element ng ating S. So kung titignan natin, meron tayong mga examples dito. 0 is less than or equal to 1. 1 is an element of S. Okay? For 2 na element ng S natin, di ba, negative 1 is less than or equal to 2. And for 0.5 na element din ng S natin, we have 0 is less than or equal to 0.5. When in fact, lahat ng elements ng S natin, meron tayong makukuha na number which is less than or equal to that element. Therefore, we say that, yes, there are lower bounds for set S. For the second question, does S have upper bounds? So para ang tanong dyan is, meron bang U, let's say U na element ng R, such that yung U na yon is greater than or equal to X for all, para sa lahat, for all X na element ng S natin? Okay, so check natin. For example, meron tayong 1 dito. So meron tayong nakuhang 2 na greater than or equal to 1. Kung may 2 naman tayo na element ng S, meron din namang 5 or 4 or 3 or whatever na greater than or equal to 2. But we know that our set S is to positive infinity siya. Okay? So, anong number ngayon ang mas malaki kesa yung mga elements ng S natin? So, we say that no. S have no upper bounds. Kasi nga, papuntang positive infinity siya. And we know that kapag positive infinity siya, meron ba? Meron bang number? Di ba wala? Kasi nga, pataas lang ng pataas yung set natin, yung elements niya. Question number 3. Does infimum of S exist? So, dito naman, titignan natin yung kanyang mga lower bounds. Meron ba siyang lower bounds? Yes, sabi natin kanina, meron. Well, actually, ang lower bounds niya ay yung set of X which are less than or equal to 0. And observe that yung 0 na yon, actually, that is the greatest lower bound. Therefore, the infimum of S is equal to 0. Does the supremum of S exist? So, i-check naman natin yung kanyang upper bounds. At sabi nga natin kanina doon sa letter B, wala siyang upper bounds, right? Therefore, supremum of S does not exist. Ngayon naman, check natin itong set na ito. Set A, which contains 2x plus 5 greater than 0 for all x na element ng set of real numbers natin. Let's see kung meron ba siyang infimum at supremum. So, paano natin gagawin yon? Actually, madali lang ito. Kailangan lang natin kunin yung bounds ng x natin. So, if we solve for x, we have 2x plus 5 is greater than 0. Ngayon, since x lang ang gusto natin, i-transpose natin yung 5 dun sa kabila. So, we have 2x is greater than negative 5. And then, we divide by 2. So, we have x is greater than negative 5 over 2. This means that yung a natin is actually the unbounded negative 5 over 2 to positive infinity. Therefore, the infimum of A now is negative 5 over 2 and the supremum does not exist. For this set B, which contains all x na element ng R, where x is less than 1 over x. So in this case naman, tignan natin, if we solve for x, we have x is less than 1 over x, then by cross multiplication, that is just equal to x squared less than 1. Note that x should not be equal to 0. Kasi nga, di ba, dito sa una nating inequality, hindi pwede ang 0 dyan. Since we have a quadratic inequality, we can transpose 1 doon sa kabila. Okay? So that becomes x squared minus 1 is less than 0. And then if we factor that out, that is just equal to x minus 1 times x plus 1 is less than 0. So in this particular example, maganda na magkaroon tayo ng table para mag-test ng signs. Okay? So ito yung gagawin natin para makita natin kung ano ba yung values ng x na magsasatisfy doon sa inequality natin. Okay? Note that ang kinukuha natin dito ay yung mga values ng x kung saan less than 0 itong function natin na ito. Okay, by test value, kuha tayo ngayon ng number na less than negative 1. Let's say negative 2. At pag plinag-in natin yung negative 2 na yon dito sa ating function, makikita ninyo na ang sign na makukuha natin ay positive. Ngayon naman, kuha naman tayo dito sa interval na negative 1 to 1. So, since hindi pwede ang 0, sabi natin kanina, so mag-check tayo like 0.5. Okay? 0.5. So, yung 0.5 naman na yan, again, i-plug in natin dito sa function natin. At ang sign na makukuha natin ay negative. And finally, kuha tayo dito sa 1 to positive infinity. Let's say 2. So, kung pinag-in naman natin yung 2 dito sa ating function, makikita natin na ang sign niya ay positive. And since ang kinukuha natin ay yung etong function will be less than 0, ibig sabihin kukunin natin yung interval kung saan siya negative. And that is from negative 1 to 1. This means that B is actually in the set containing the interval negative 1 to 1 except 0. And clearly, makikita natin dito that the infimum of B is negative 1 and the supremum of B is 1. For the last example, we have the set C, which contains all x element of R, where x squared minus 2x minus 5 is less than 0. Notice that our quadratic expression here is not factorable. So, gamitan natin siya ng quadratic formula para ma-factor.
Negative b plus or minus the square root of b squared minus 4ac over 2a. Negative b plus or minus the square root of b squared minus 4ac over 2a.
By solving x using the quadratic formula, we have this inequality. Medyo mahaba. And then, if we simplify that, that is equal to that. Further simplification, this becomes x is greater than 2 minus the square root of 24 over 2, but less than 2 plus the square root of 24 over 2. Or that is this. Ngayon, pwede nating ilabas yung 4 because the square root of 4 is 2. We have this. And then if you cancel 2, kasi pwede natin siyang i-factor, this becomes x is greater than 1 minus the square root of 6, but less than 1 plus the square root of 6. This means that C is actually the interval 1 minus the square root of 6 to 1 plus the square root of 6. Thus, the infimum of C is equal to 1 minus the square root of 6 And the supremum of C is 1 plus square root of 6.